As promised, we're back for a little bit more solving with exponential and log equations. Our last video looked at 4 problems that probably felt fairly different. The first 2 were a little similar, and then the third and fourth felt, I would say, fairly different. So in this video, I just want to do probably 3 more problems, and then any additional questions that you all have as you're working on exit slips, homework, quizzes, etc., shoot them my way, and I can always make extra videos to add to. So let's just dive right in. In the last video, we began by mentioning some strategies. I think we'll hit those strategies through some examples as we work. So let's say for our first example, we were given -6 log base 8 of 10x is equal to 6. So that would be a logarithmic equation to begin with. And we just want to think about a good solving strategy. So at first glance, maybe an intuitive step is to try to isolate the log because the log involves the variable, right? So you got to kind of check out where is the variable that you're trying to solve for. So I'm going to make my first step here. Hopefully this is an intuitive one, dividing by -6 because my goal is, again, to be able to isolate x. So by dividing by -6, now the left-hand side is log base 8 of 10x. And on the right-hand side, we get equals -1 now. Log base 8 of 10x equals -1. In that line, I feel like my x, the variable I'm trying to solve for, is fairly locked up. So I'm hoping this starts making you think of this rewrite form, right? The rewrite from logarithmic to exponential. Getting rid of the log would definitely help in this problem. So if I rewrite log base 8 of 10x equals -1 in exponential form, the base of 8 drops, -1 crisscrosses, and it's equal to the argument. And from there, that's actually just a linear equation in hiding, so I think we're going to be fine to finish solving this one. 8 to the power of -1, that's a little weird looking 8, 8 to the power of -1 is really the same as 1 over 8, right? If you have a negative power, you can push it down to make it positive. So 1 over 8 to the first is just 1 over 8. And if I'm trying to solve for x, I would just need to divide by the 10. Divide by 10, divide by 10. And dividing by 10 maybe is perhaps a little nicer written in this problem as multiplying by 1/10. So I'll write it that way just to help everybody see that last step there. So dividing by 10 is the same as timesing by 1 over 10. So that means our solution for x is going to come back as just 1/10 times 1/8, which is 1 over 80. So that would be our solution. Again, you guys can readily check this by plugging it back into the original. Folks who like graphing, graph the left side and the right side and make sure the x coordinate of intersection is at 1 over 80. So the technique that we just used in this example was rewriting log form as exponential. So rewrite log form as exponential, and that really solved our trouble with this one. So that's a good technique. We haven't seen that one yet together. Let's tackle another one. I'm going to throw another natural log your way just to keep using log logs and ln, which is just our log base e. So now let's say we're going to find an exact solution for 11 plus 7 times the natural log of x plus 2, and we'll just set that equal to, let's see, 35. All right, so again, put on your old algebra hat, think about how would you start getting x alone, right? Here's my x term. So in this example, again, hopefully a good intuitive step is moving the 11 over to keep working on getting the term with the x alone. So that gives us 7 ln of x plus 2 on the left, so it doesn't feel that much better. On the right, that's equal now to 24. Now, maybe it makes sense to get the ln term alone by dividing both sides by 7. So that'll leave us the natural log of x plus 2 on the left and 24 over 7 on the right. Now what? Our goal is to get x alone. An ln stands in our way. Well, we could use a very similar technique as we did in the last example, which is remember that ln is really just a log base e. And if we write it that way, then we could change it to exponential form. So that would definitely work. The other idea I'm going to recommend is really not that much different, but it goes back to our knowledge of inverse functions. So if I have an ln standing in the way of what I want, I can undo ln using its inverse, and the inverse is e. So I'm going to take e of both sides, and everything I have then gets exponentiated. It becomes the power. And when we do that, again, our knowledge of inverses helps inform us that on the left-hand side, e and ln cancel, leaving just x plus 2. On the right-hand side, we have e to the 24 over 7, whatever that is. I'm not stressed about getting a decimal form because I'm finding all our solutions exactly in these problems. So real quick, we'll just subtract 2 from both sides. And negative 2 plus e to the 24 over 7 would be our exact solution to this equation. And I'll just keep reminding us exact just means it's okay to have an e or a log in our answer. Exact means we never rounded. So we never punched it into a calculator and rounded the decimal. So again, slightly different feel to that one. Hopefully that feels pretty good. I'm trying to get a little bit of e and ln practice mixed in here. So we'll just try one more problem and then I'll leave it to you guys to reach out with any other questions or comments about solving. I look forward to hearing what you think of these. Let's find an exact solution now to this example. Let's take the natural log of 5 and we'll add it with the natural log of 5x squared minus 5. We'll set it equal to the natural log of 56. I like this example because it allows us to use the product property, which we haven't talked about too much. So remember, if we have two logs of the same base being added, we can compress that to a single log where the quantities are then being multiplied. So this is that product property that we learned. And right away that helps the problem feel a little better because now we have log of something on the left equaling log of something on the right. Now, because both sides have the same type of log, it's a log base e or an ln, we can use e again to undo ln. And basically what that's going to do, I'll show the end result and then we'll show the in-between step, is the ln's will cancel. So we'll just have 5 times 5x squared minus 5 equals to 56. So a lot of times I see people just cancel these out on both sides. That's technically okay. I mean, they're on both sides, so you can remove it from both sides. If you want to show a little bit more work for that step, I'll just show exponentiating with e on both sides. And then that's definitely justification for why it cancels out. So e to the ln of stuff will equal just stuff. Okay, so the e to the ln cancels, leaving just those arguments. Now the resulting equation is quadratic. We are pretty solid on solving quadratics, I would say at this point. So I'll divide both sides by 5 to get 5x squared minus 5 equals 56 over 5. Looks like I'm going to add 5 to both sides, so this one has a little fraction work to it. Hopefully we will embrace that together. So I'm going to add 5 or 5 over 1 to both sides. I'll show my work by hand to get a common denominator. So this 5 needs to be This 5 over 1 needs to be brought up to the least common denominator of 5, and we can accomplish that just by timesing top and bottom by 5. So we have 5x squared on the left equal to 56 over 5 plus 25 over 5. Because those fractions have the same denominator, let's go ahead and add the numerators. So 56 plus 25 sounds like an 81 over 5. Our goal in solving for x would probably lead us next to divide both sides by 5. Remember, dividing by 5 is the same as timesing by 1/5, so in case that looks a little nicer, I used that idea earlier as well. That'll leave us just the x squared on the left, and 81 times 1 is 81, 5 times 5 is 25, and here we go, another inverse relationship. So to undo squaring, we will square root both sides. Algebraically, that gives us back plus or minus, and the square root of 81 sounds like 9. The square root of 25 sounds like 5. And typically, anytime you're solving, you should think about whether the solutions are valid. I'm going to just float back up to the original real quick. If the x in the original wasn't squared, if it had the potential to make this piece a negative, I would be in trouble. But the x is being squared, so I'm guaranteed that the argument is still positive. So both of these are valid solutions, the plus 9/5 and the minus 9/5. I'll leave it to you guys again if you want to either plug it in or graph the left and right side in Desmos and make sure these are the x coordinates of the intersection. So let me know what you think about solving. More than happy to make some more videos based on questions or other examples you'd like to see.